Okay, so I'm having trouble with my recorder today, so let's try this one more time. I've tried it 3 times and I keep hitting the wrong button or something. Let's see if we can get through this. Data clustering. So, what is data clustering? Well, in general, right, you're just given a bunch of data. Here's some data, and the problem is, excuse me, we want to determine if there are any groups in the data, kind of natural groupings of points. And if there are, then we'd like to know, which points belong to which group. And so, in the general case, we're just given data points, and we return uh, the cluster index, maybe I should say. Okay, so we'll talk about that more in a second. So what we're actually doing here is building a function, right, membership function. But in this general case here, this is called an unsupervised learning problem. Because we're not told anything about how to separate the data, right? We're just given raw data points with no indication of who belongs to what, and then we have to figure it out. Versus, if we had there might be problems like, if you know which customers are buying certain things, you might say that, you might have a cluster of customers buying product A versus customers buying product B versus customers that buy product C. And so in this case, this is a labeled problem, right? And so this is a supervised task. And in this case, the function is really different. Because we already know class membership, we're really just building, we're trying to figure out the boundaries between clusters. So in this case, we focus on the boundaries between clusters rather than building the clusters themselves. And so the algorithms that you would use to solve the supervised task are a lot different than the unsupervised learning task. Okay, and so in fact, I would say that this is the classification problem. And so we're going to learn how to solve that. We're going to build classifiers later. While the other side here is the unsupervised learning problem. And so in this case, the problem is a lot harder to solve, right? Because again, you don't know how many clusters there are in your data in general. So some algorithms require the number of clusters that you want, number of clusters to produce, and some will try to determine the number of clusters. And of course, it is nicer for the program to go ahead and try to determine the number of clusters, but then you have extra parameters that you have to set. Well, there are other parameters to have to set, I should say. Some algorithms, so the ones that have the set number of clusters are a little bit easier to program in because you already know in advance how many clusters you're going to be using. Okay. So those are a couple of features of data clustering that we're going to be thinking about in our different algorithms. But all in all, I want to kind of give you a formal definition here. So a clustering task, an unsupervised learning task. Unsupervised learning, let me say unsupervised clustering is building a membership function that we might call m of a data point xi is equal to k, where k is the index of the cluster to which xi belongs. Right, so in our previous example that we had, if I put this point into my function, if this is my point 1, then that might have label 1, and so all of these points would have label 1, right? And then these might be label 2, and these might be label 3, and so on. They could have, the index that you're using could depend on, which points you're starting with. Okay, so that part of it is not as important as just the separation between the three. Okay, good. So we always have two extreme clustering measures, or two extreme clustering functions. And we typically want to avoid these. One, where m of xi is equal to 1 for all data points, for all I. Okay, this is just taking the set and just saying, here's all your data, it's in one cluster. So that's not very informative. The other extreme class may be that m of xi is equal to I. And in this case, every data point has its own cluster. And of course, you want to avoid both of those extremes. So we want to somehow get in between here, right? We want in between. So hopefully that we'll be able to, this is the problem where we don't know the number of clusters, right? And so to avoid this problem, yeah, some algorithms will require the value of k, the value of the number of clusters. Because of course that's one way of avoiding that. Good. All right. So before we get into the clustering itself, there is one way to talk about just points in the plane, and that is through the Voronoi cell. So I want to take a moment just to define what a Voronoi cell is in the plane. So Voronoi cells in the plane. So these exist separate from clustering, although the clustering does something similar. So just let a few points, C, I, these are vectors in the plane, I equals 1 to k, bk points in the plane. Okay, these are going to be the centers of our Voronoi cells. So we might have, Voronoi cells like that somehow. Okay. Then, what is a Voronoi cell? Data point x. Maybe I should use a different symbol there. Data point xj. Oh, let me do this a little bit differently. Let me keep to the books or the notes notation. So Voronoi cell v sub j is defined to be the set of x in Rn such that the distance between x and cj, is less than or equal to the distance from x to any other center, ci. for I equals 1 to k, however many centuries you've got. Okay, now if it's equal, right, that's you could really take membership to be either on either side. There's ways to break the tie. Sometimes we just choose the index that's smaller. That's a random choice. Okay, but what does this look like when you separate data like this? This is kind of a natural separation of data. Um, you get something that looks. I'm connecting the dots here because the boundaries between the data points are actually orthogonal to these lines here, and so you can kind of connect the dots by drawing these lines. If you're lucky, they'll connect nicely, but they may not. Well, since I'm drawing this by hand, I'm going to draw them like that. Okay, and so drawing these boundaries, we don't usually see those, but these are drawn in the Voronoi command. Voronoi command in Matlab and Python. Usually will plot the boundaries of your region. And so those are kind of fun to look at. And so just as a quick note, Matlab, we might say something like if x is equal to some random numbers, rand n, 10, 2. So that's 10 points in R2. So that's a tall matrix, right? Then you can just say Voronoi, x. It's a tall matrix. Okay, and so then MATLAB will run through and plot the data. I believe it plots the data automatically. Python, there's a little bit of upkeep in Python, right? Because we have to define where in the libraries we're going to find our functions. I'm going to let you read that, but just to give you an idea, so the Voronoi diagram stuff is in the SciPy .spatial library. Okay, so we'll have to import a few things, and then those are in the course notes. Okay, so we have one more quick thing to identify, and then we'll talk about a specific algorithm called the k-means algorithm.